In today's video, we will be talking about linear regression. We will learn how to create a scatter plot, find the least squares line, and use the least squares line to make predictions. For this lesson, we will be using a data set about an infant's head circumference, where X is the infant's age in months, and Y is the infant's head circumference in inches. Our first step is to create a scatter plot of the data, like the one shown here to the right. To do that in our calculator, we will go to Stat and Enter, and we will enter our X values of the infant's age in months into list 1, and enter our Y values of the infant's head circumference in inches into list 2. Once we've done that, then we want to view our stat plot. To do that, we need to make sure that our stat plot is turned on. So we go to second Y equals, or second stat plot, and press enter, and enter again to turn plot 1 on. Notice that our X list is L1, which is our infant's age, and our Y list is L2, which is our head circumference. Now, to make sure that we have a good viewing window, we want to quit and check our viewing window. We're going to press zoom and arrow down until we get to zoom stat and click enter. Now we see a good picture of our data points, which is our scatter plot. Notice that the data points lie approximately in a line, which means that a linear function may give a good approximation of the data. If we select any 2 points and find the line passing through them, we will get a different line for each pair of points, and in some cases a very different line. We want the line to be as close to all the points on the graph as possible. So how do we decide on the best line? Should we pick 2 strategic points like the first and last? Well, that's a good idea, but it's not the best idea. We will choose our line of best fit as the least squares line. The line in which the sum of the squares of the vertical distances between each point and the line is as small as possible. This is a complicated and tedious calculation to do by hand. Thankfully, our calculators can find the least squares line with just a few keystrokes. To do this, we go to Stat and arrow over to Calculate, or Calc, and down until we get to linreg ax plus b for linear regression. Now, we want to make sure that our X list is L1, again, that is our age in months, and our Y list is L2, which is our head circumference in inches. If you have an old calculator, you will have to click second 1 to get list 1, and then click comma, and second L2 or second 2 here to get L2, and then click enter. So we will click calculate, and now we have our line of best fit, which is our least squares line in slope intercept form, y equals ax plus b, where a is our slope 0.456 and b is our y-intercept 14.5. If we want to view that on the graph, all we need to do is press y equals and enter in our line, which is 0.456x plus 14.503, and press graph. So we have created our scatter plot and found our least squares line. We often use past data and trends to make tentative predictions about the future. Of course, they are not exactly correct, but they should be reasonable. So, let's use our least squares line to make predictions. For example, what do we predict the infant's head circumference will be at 7 months? All we have to do here is plug in x equals 7 into our equation for the least squares line. When we do that, we get 0.456 times 7 plus 14.503, and if we enter that all into our calculator and press enter, we get y equals 17.695 inches, which looks pretty reasonable compared to our other data points. We can also use the least squares line to approximate x values. For example, when was the infant's head circumference 15 inches? Here, we need to set y equal to 15 and solve for x. This will require a little bit of algebra, but nothing too tricky. So let y equal 15 and set that equal to 0.456x plus 14.503. Then we need to subtract 14.503 from both sides, and then we need to divide both sides by 0.456. And then we get x equals 1.0899, or if we round to 3 decimal places, 1.090 months. If we multiply our decimal portion times 30 days in 1 month, then we get 1 month and 3 days, which looks in line with our other data points.